Next 2019 Shift 2 question 1. A spherical copper particle has about 125 atoms. If the atomic radius of copper is 140 picometers, the diameter of the particle is close to the wavelength of green light. Electron beam of energy 1.4 electron volts. Sound waves of frequency 340 Hz traveling in air at room temperature. X-rays of energy 12.40 kilo electron volts. Just a second. It's too much noise. Okay, so first of all we note that 125 is the cube of 5. Okay, and we know that the volume is proportional to cube of the radius. That fact could be useful. Okay. Okay. Now they are saying that atomic radius of copper is 140 picometers. Okay, atomic radius of copper. So can we find out the volume of one copper atom? Yes, that will be 4 by 3 into pi into 140 into 10 raised to negative 12 meter cube raised to 3. Okay. Now if we go for the volume of the copper particle, and mind you they are saying it is spherical. Okay, volume of spherical copper particle. Okay, so it will be greater than 125 into this number. Raise your hands if you understand this, because in that we can say copper drop, there will be those 125 atoms, and then from this we can get an estimate of the radius. Okay, let's call it R spherical. Okay, R spherical will be greater than, now as I pointed out 125 is the cube of 5, so R spherical will be greater than 5 times 140 into 10 raised to negative 12. Okay, 5 into 140 into 10 raised to negative 12. Okay. Okay, now what will be the diameter then? D spherical. It will be greater than 700, okay, into 10 raised to negative 12. Okay. Okay, so we can roughly say, now see, look, we are ignoring the interatomic spacing. Okay, we are ignoring the interatomic spacing because there is no way we know that particular value for copper, or for that matter any other atom, okay, or any other metal. Ignoring interatomic spacing, D would be approximately equal to 700 into 10 raised to negative 12 meters. Okay. Now yes, sorry. This is radius into 2. So this will be 1400. My bad. Yeah, 1400 into 10 raised to negative 12 meters. Okay, let's start with the first one. Green light. Green light is, okay, now look, lambda visible is in the range 400 to 700 nanometers. Okay, now can we get this in nanometers? D. It is 1400 into 10 raised to negative 12. Okay, so that will be 1.4 nanometers. Correct? Is that right? No, it's not right. So option A is gone. Let's now go to option B. Okay, well, let's go to option B. See, definitely there is a very little chance that C is going to give us the right option, right? Sound waves of frequency 340 hertz. We know that's never going to be true, because look, lambda nu is equal to V, and if wavelength is if the frequency is 340 hertz and speed of sound can also be taken as 340 meters per second, then wavelength will be 1 meter. So no way that is going to be right. So it's either B or D. Okay, either B or D. Let's go to B. Let's go to B. Electron beam of energy 1.4 electron volts. Now this is now a dual nature of matter formula. Lambda is equal to h by root of 2m into k. Okay, so let us find that now on calculator. (1.4) into 1.6 into 10 raised to negative 90. Okay, let's do it quickly here. 6.626 into 10 raised to negative 34 upon root 2 into 9.1 into 1.4 into 1.6 into 10 raised to negative 50. Okay, so this is now 1.03 into 10 raised to negative 9. And what was our answer? 1.4 nanometers. So pretty close to that. 1.4 nanometers is very close to that, so we can mark it. But let's go to D and check whether it is closer to D than B. Okay, X-rays of energy 12.40 kilo electron volts. Okay. So here we have to use the formula E is equal to h nu or hc by lambda. We want wavelength, so it will be hc by E. 6.626 into 10 raised to negative 34 into 3 into 10 raised to 8 upon 12.4. Don't forget it is kilo electron volts, so into 10 raised to 3 into 1.6 into 10 raised to negative 90. Okay, let's do it. 6.626 into 3 into 10 raised to negative 34 plus 8 upon 12.4 into 1.6 into 10 raised to negative 60. Yes, now this is into 10 raised to negative 10. Okay, so this is of the order of 0.1 nanometers. Okay, 0.1 nanometers, and our value is 1.4 nanometers. So which one is the closest? Option B is the closest, not option D. ठीक है, B is the closest, not D. So B.